Alright, so we're going to try out the graph of a hyperbola from the given equation. It says we're going to use vertices and asymptotes to graph the hyperbola, then locate the foci and find the equations of the asymptotes. This is centered at 0, 0. I'm just going to make a little mark here showing the location of our center. We're going to start by making this box with dotted lines is what we're going to start with. And so looking at the denominator of the x, we're going to take the square roots of 16, which gives us positive 4, negative 4. These are going to be the boundaries of that dotted line box in the x direction. And then the denominator under the y squared, if we do the square roots of 25, we get 5 and negative 5. It's going to be the boundary of our box in the y direction. So we're going to connect this down, make this into full rectangle shape, dotted lines. All right, and then next we are going to draw in the asymptote lines. So the asymptote is going to cut through our center and it's going to perfectly go through the corners of our box. We're going to do those with dotted lines again. Okay, next we're going to look and see which variable comes first. So the x squared comes first, and so like I told you before, the way I remember it is that it's going to be this shape like this, because if we put them closer together, it reminds me of an x. And so the vertices are going to be at the edge of the box on top of the x-axis. So the vertices are going to be 4 and negative 4. And then we are going to draw our curve upwards, kind of inside of those asymptote lines to look something like this. All right, so we have done the first part, graphed our hyperbola. Now we're going to locate the foci. So we're going to use the c-squared equation for a hyperbola. C is the distance from the center to a focus point. All right, so we can estimate the value of square root 41. 41 is in between 36 and 49. Square root 36 is 6. Square root 49 is 7. So this is going to be somewhere between 6 and 7, which just kind of estimates 6 point something, maybe 6.5. If you plug this into your calculator, you can get something more accurate. But this is kind of how you could think about it if you didn't have a calculator. And so if we go back over here to our center, if you go count somewhere in between 6 and 7 spaces, we're just going to mark a point there to show the location of the foci. And when we list out the ordered pairs, we're going to do the exact value using the square root symbol, no decimal approximations. These are x-intercepts. So we are going to list square root 41 first, comma 0, and the other is negative square root 41, comma 0. So we've located the foci. And then we want to give the equations of the asymptotes. So we're going to think about the slope. Starting at our center, we go up 5 over 4. So the rise over the run is 5/4. And we've got one positive and one negative. Okay, let's try another one. So again, we're just going to start by creating our box. We're going to look at the number underneath the y squared is 9. So in the y direction, it's going to be 3 and negative 3. Again, this is assuming that we're centered at 0, 0. The number underneath the x squared is 4, so we're going to think about those square roots, 2 and negative 2. So that's going to be the barrier of our box on the other side. We're going to draw in the asymptotes. So the asymptotes are going to cut right through the center, and those are going to perfectly go through the corners of our box. If you have a ruler, that might even make this process a little bit easier. Now let's pay attention to the y squared is in front, and so that means that our hyperbola is going to be this shape. So the vertices are going to be on the y-axis. We're going to do the vertices at the edge of the box at 3 and negative 3, and then we're going to draw our curve passing through the vertices, and just kind of getting closer to the asymptotes. The asymptotes are a little bit of a barrier for how far out that curve is going to go. So we've completed our graph. Now we're going to locate the foci using our c-squared formula. So we add our denominators together. So that's the square root of 13. If we're estimating this location without a calculator, we can think that 13 is in between 9 and 16. The square root of 9 is 3. The square root of 16 is 4. So 13 has got to be somewhere in between 3 and 4. So again, we can just maybe estimate something like 3.5. So if we go up 3.5, these are going to be really close. Like it's going to be something like here and there. The foci are very close to the vertices, but they are just barely on the other side. So we see that the foci are y-intercepts this time. So when we list out their coordinates, we've got 0, comma, square root 13, and 0, comma, negative square root 13. Next, for the equation for the asymptotes, we're going to look at a center. We're going to look at the rise over the run. So this time it's up 3 over 2. So it's going to be 3 halves x. And the other asymptote is going to be negative 3 halves x. Next, we're going to practice rewriting an equation in standard form. The standard form, when the x is in the front, is going to look like this. We need to have it set equal to 1. And so in order to get this side equal to 1, we are going to divide that by 100. If we do the right side divided by 100, we've got to do everything on the left side divided by 100. So this first part here, that 4 100ths, is going to simplify to 1/25. So we get x squared over 25. 25 100ths simplifies to 1/4, so we get y squared over 4, and all of that is equal to 1. Now that it's in the standard form, we can more easily make a graph. In the next problem, we're going to work backwards using some given information to find the standard form of the equation of a hyperbola. This time it tells us the foci are at -5 and 5. The vertices are at -3 and 3. So we're going to start by just making a sketch of this. Draw an xy axis. All of these points that we're given are y-intercepts. So let's do y-intercepts at 5 and -5. Vertices are at 3 and -3. And so that means that our hyperbola shape is going to look something like this. This tells us that the y squared is going to be in front. Equal to 1. So in the y direction, if we think about the box, in the y direction, it's going up 3 and down to -3. Those are the square roots of the number below the y squared, and so that must be 9. Now we need to figure out the value of b squared, and so we can do that using the c-squared formula. Off to the side here, we know that c squared is a squared plus b squared. Okay. So we know that c is the distance from the center to each foci point. So this tells us that c is 5, so c squared would be 25. A squared, we know from before, is 9. Subtract 9 from both sides, so we get b squared is 16. Okay, we're going to try this again. So we want the standard form, again, of the equation of a hyperbola. This time, the given information tells us that the foci and the vertices are both x-intercepts. So let's plot one focus at 4, vertex at 2. We've got a vertex at -2, and our last focus is at -4. So we know that the hyperbola is going to go through the vertices. So this tells us that it's going to be this sort of shape, and because it's in that shape, the x squared is going to come first. All right, so the number below the x squared is going to represent If we take a look at the box, the edges of the box go out 2 and back 2. Those are the square roots. That is actually the A distance, so we can see that from the center, A is 2, so A squared would be 4. All right, now again to find B squared, we're going to do that C squared formula. This time, C is the distance from the center to a single focus point. We get that C is 4, so C squared is 16. And I just pulled the A squared over here. We already knew that that was 4. So subtract 4 from both sides. We get that B squared is 12. Next, we're going to look at hyperbolas that do not have a center at 0, 0. So now we have a new center. We're going to call our new center HNK. Similar to the ellipse, we can shift it left, right, up, or down. All right, so we're going to try out this graph. We're going to start by identifying the center, and we're going to think the general form of this, x minus h squared over a squared, y minus k squared over b squared equals 1. And in this form, the center is hk. All right, so when we look at the number inside the parentheses with the x, we're going to change the sign. So the x value of our center is -2. And the y value of our center, you can think of this as y minus 0. And so it's just going to be a 0. So let's plot that new center. It's going to be an x-intercept over here, -2, 0. Now we're going to make that box the same way that we did before. So the number underneath the x squared part is 9. The square roots of 9, we get 3 and -3. So from the center, we're going to count 3 spaces to the right, count 3 spaces to the left to get the boundaries of the box in the x direction. And underneath the y squared, we're going to go up 5 and down 5, so the square roots of 25 are 5 and -5. Connect that all together, turning it into a box. And then we're going to draw in the asymptotes. So the asymptotes are going to pass through the center and they're going to pass through the corners. The x squared comes first, and so that tells us that the shape is going to look like this. So we're going to make the vertices at the barriers of our box in the x direction on top of the x-axis, and then we're going to draw our curve going through the vertices and getting closer to the diagonal asymptotes. All right, so we've done our graph. Next, we're going to locate our foci. So we're going to calculate the c squared distance. This time we're doing 9 plus 25, which gives us 34. So that distance is square root 34. That's going to be a little bit less than 6 because the square root of 36 is 6, maybe 5.8 or 5.9. So if you think about the location on the graph, if you start at your center and we count 1, 2, 3, 4, 5, a little more than 5 spaces in that direction. And then on the other side, 1, 2, 3, 4, 5, it's going to be about 5.8. So we're just kind of estimating the location. We see that the foci are both x-intercepts, and so we're going to write them as x-intercepts. So we've got square root 34 comma 0 and negative square root 34. I am sorry, I just realized my mistake here. You may be thinking the same thing. So we are going to start at the x value of -2. If you do -2 plus square root 34, that's what gets you this one. -2 minus square root 34 is going to get you the other one. And the y value is 0 for both of those. All right, so thanks for bearing with me on that one. Now we're going to get the equation for our asymptotes. Let me just erase some space here. So we also want to think about the asymptote equations a little bit differently on these when it's not centered at 0, 0. When it's not centered at 0, 0, we are going to use this point slope general form for a linear equation. and that looks like this. And so in this equation, we're going to keep the x and the y as they are. The parts that we are going to be plugging in are the rise over the run. One is positive for the positive slope, one is negative. And then we're going to plug in the x1, y1. That is going to be a point, and typically we use the center for that point. So let's try this out. Let's say that x1, y1 is equal to our center of -2, 0. And I just need a little bit more space here. I'm just going to bring all of this down below. So we have y minus y1, so y minus 0. The rise over the run this time, we went up 5 and then we went over 3, so it's 5/3. And then it's x minus -2. So altogether, we've got y equals plus or minus 5/3, x plus 2, and those represent two equations, the one plus, one minus. Those represent the equations for our asymptotes.